Hi, I'm Nadine Keynindra from Architecture. Hi everyone, my name is Puti Khairani from Industrial Engineering.
Hi, I'm Besdalovaro from Metallurgy and Material Engineering.
Hi, I'm Muthia Qinthar from Architecture.
And we're from Pythagoras Group.
Did you know Pythagoras don't like eating beans in his meals?
Wait, who's Pythagoras?
You know, good philosopher, mathematician, the one who created the Pythagorean theorem.
What is the Pythagorean theorem?
Okay, so it's basically a mathematical formula which states that the hypotenuse of a right triangle is equal to the square of the other two sides.
Wait, do you know someone has already found the similar theorem before he did?
No!
So this definition of derivative, f prime of x equal to y prime equal to the limit of h approaches to 0 and f of x plus h minus f of x over h. For example, this one, f prime of x equal to 2x and plus 5.
Now let's talk about the power rules of derivative. Derivative of a variable raised to a constant such as x to the n is equal to n times x raised to the n.
The use of derivatives to our daily life. These days, almost every building has elevators or escalators. The movements of those elevators and escalators can be illustrated by using decreasing and increasing functions. You can also use derivative to calculate the profit and loss in businesses using graph. Also to check the temperature variation to determine the speed or distance covered such as miles per hour, kilometers per hour, etc. Derivatives are also used to derive many equations in physics. And one more, in the study of seismology, you can use derivatives to find the range of magnitudes of the earthquake.
Okay, for the next part, let's talk about how to find the derivative. First, let's talk about the constant type. The derivative of any constant is equal to 0. For example, if the question asks what is the derivative of 2, then the derivative is 0. Okay, so let's move on for the second type, which is the monomial part. So the derivative of any variable raised to a constant such as x to the n is equal to n times x raised to the n minus 1. So in this part, I will explain more of the example of the questions. So the question is, a system y is specified by time t. It follows the function y of t equal to 2t cubed minus 3t squared plus 3. And please find the interval when y of t increasing and or decreasing if it exists. So the first step that we will do is find the derivative of the functions. So the function is y of t equal to 2t cubed minus 3t squared plus 3, and the derivative is y prime of t equal to 2 times 3t of 3 minus 1 minus 3 times 2 t of 2 minus 1, and the answer will be 6t squared minus 6t. So for our next part, we're gonna change the y prime of t into 0, because in this way we could find the answer for the t, and the function is gonna change into 6t times t minus 1, and for the 6t is gonna change into t is equals to 0, and for the t minus 1, the answer will be t equal to 0, equal to 1. Then the interval will be like this. Why is it plus minus then plus? There's a way that we could do to find that, and in this part I'm just gonna explain it a bit. I'm just gonna take from this area because it's below 0. Then I'm just gonna take one of the numbers. It is minus 1, and this minus 1 we're gonna apply into these functions. So it's gonna change into 6 times minus 1 times minus 1 minus 1, then equals to minus 6 times minus 2. Then the answer will be plus. This plus and this plus is the same thing, so it applies for this interval. So there's gonna be two answers for this question. The first one is y of t increasing when x more than 0 or x less than 0. And for the second answer is y of t decreasing when 0 less than x less than 1.
Moving on to the second question, which is find the third derivative of this equation. So what we want to do is to change the equation into f of x equal to 4 times x to the power of 3 over 5 minus 8 times x to the power of minus 2 minus x to the power of 1 over 2. Now we find the first derivative, which is 12 per 5 times x to the power of minus 2 over 5 plus 16 times x to the power of 3 minus 1 over 2 times x to the power of 1 over 2. Then the second derivative, which is minus 24 over 25 times x to the power of minus 7 over 5 minus 48 times x to the power of minus 4 plus 1 over 4 times x to the power of 3 over 2. Now lastly, the third derivative, which is 168 per 125 times x to the power of 12 minus 12 over 5 plus 192 times x to the power of minus 5 minus 3 over 8 times x to the power of 5 over 2. And that's how you get the third derivative.
That's all from us. Thank you. Bye.